Hello everyone, welcome to another exciting video tutorial. In this edition, we're delving into something truly special, designing and building a three-phase, four-source automatic transfer switch ATS panel. This isn't just any panel, it's a versatile system allowing us to seamlessly switch between multiple power sources, the utility grid, a diesel generator, a fuel generator, and a 7.5 kVA solar inverter system, all to power your household effectively. Imagine the possibilities. With this three-phase ATS panel, we can switch between these sources effortlessly, directing power to a single load, safely and efficiently. But that's not all. When the grid is functioning properly, our system can turn off the generators, preserving fuel and preventing unnecessary wear. And if the grid supply goes down, our intelligent design ensures that the diesel generator fires back up to keep your home running smoothly.
Let's break down how this setup works. In its default state, the ATS panel operates on the 7.5 kVA solar inverter source, providing a robust three-phase alternating current or AC output to your household supply. So whenever there's sunshine, you're harnessing solar energy for your needs. How great is that? Next, our system is equipped to sense input from the grid. In my country, we call it NEPA. When this three-phase AC input is detected, the ATS automatically switches to the grid supply, ensuring you're always powered. Then we have the fuel generator. This generator provides a single-phase AC voltage input, and its capacity is capped at 30 amperes. Finally, the heavy lifter, our diesel generator, which is also a three-phase input source, stepping in when needed.
Selector switches and their magic. The ATS panel is controlled by two selector switches, aptly named Selector Switch A and Selector Switch B. Each switch can move left or right, but in their neutral position, they stand upright. When both are upright, the system is set to its default, happily drawing power from the inverter. If grid power kicks in, it's a seamless transition to grid supply. Now, if Selector Switch B is turned to the right, it activates the diesel generator. Imagine that. When the grid fades away, your diesel generator keeps the lights on. But should the grid come back, the ATS will switch back and power down the generator, conserving fuel and extending its life. And when Selector Switch A is turned to the left, that invokes our little single-phase generator. This is especially vital on those gloomy, rainy days when solar collection isn't at its peak and battery reserves are low.
To build a system this robust and smart, you can't cut corners. You need both muscle and brains. For the muscle, we used heavy-duty three-phase contactors, each rated for their specific source. A massive 120A contactor for the utility grid, as it carries the main load. 100A contactors for both the diesel generator and the solar inverter, and an 80A contactor is more than enough for the smaller fuel generator. For the brains, we integrated multifunction time relays to control the switching sequence and eliminate power transients, ensuring a smooth, safe transition every time. A voltage protector to guard against dangerous undervoltage and overvoltage conditions, and of course, three-phase breakers for protection, AC relays for control logic, all neatly mounted on a professional DIN rail. Every single power cable was terminated with a cable lug and shrink tube for perfect, safe connections and clear phase identification. This attention to detail is what separates a professional panel from a DIY project. The build process is where the plan comes to life. It all starts with a clean slate. We spent time carefully arranging every component on the panel base. This planning phase is crucial for efficiency and a clean final product. Once the layout was perfect, we moved to the enclosure, cutting precise holes for our pilot lamps and selector switches. Then came the wiring. We started with the power side, the high current paths for the contactors. We used appropriately rated cables and made sure every connection was securely lugged. A loose connection here is a point of failure, and we don't tolerate that. After the muscle was in place, we wired the control side, the intricate network that tells the relays and contactors when to act. This is the nervous system of our panel. At this stage, as you can see, it looks a bit complicated, but that's about to change. Cable management. This is the transformation. Using cable trunks and ties, we tamed the chaos. The result isn't just about looks, although it is beautiful. A well-managed panel is easier to troubleshoot, safer to work on, and speaks volumes about the quality of the build. With the build complete, it was time for the most critical phase, testing. We rigorously simulated every possible scenario, grid failure, generator startup, solar availability, to ensure the system performed exactly as designed. Every switch, every sequence, every automatic shutdown was verified. Seeing those green pilot lamps light up indicating a successful transfer, that's the payoff. Once we were 100% satisfied, the panel was ready for packaging and delivery, giving our client the ultimate peace of mind. If you're inspired by this project and want to see the complete schematic diagram to understand the wiring on a deeper level, you can find a link in the description below. For a custom copy or to discuss your own project, feel free to reach out to us through our official handles or email. Building this 4-source ATS was a complex but incredibly rewarding challenge. If you enjoyed this deep dive into power control systems, learned something new, or you're just a fan of clean engineering, hit that like button and subscribe for more content like this. Let us know in the comments what kind of electrical project you'd like to see next. Thanks for watching, and until next time, stay powered.
Ist gut.